This video is on the period of trigonometric functions. So a function is considered periodic if there exists a positive number. We're going to call it p. So p is a positive number for which f of x plus p equals f of x. And this must be true for every single x in the domain of my function f. If this number p exists, then the smallest such number is called the period of the function. So the smallest p, or the smallest number that does this, is called the period of f. So the idea is that there's some number that exists that I could add to any input value x, and that what I end up with will be the same input value. So it turns out that sine, cosine, and tangent, in fact all trigonometric functions, are periodic functions because they have this number p, the smallest number that works for every single input, that when you add it to it, when you add that number to the input, it doesn't change the function value. So remember, we have, when we look at sine, for instance, the sine function, we want to figure out the period of this function. So if you remember, we know that sine was defined as the y-coordinate of the point intercepted on the unit circle by our angle in standard position. So imagine our angle, call it theta, and it's in standard position. It'll look something like this. We have our angle theta, and here's our point P, and we know that sine and cosine are the x-coordinates of this point. Now don't confuse the point P that I'm naming my point for this number P that is going to be the period of our function. So the coordinates x and y are the cosine and sine values of theta, respectively. Now, any angle that has point P on its terminal side will have the exact same sine and cosine values as my original angle theta. So an angle that is coterminal to theta will have the same sine and cosine values. So this means that any coterminal angles will have the same sine values as angle theta. So coterminal is our key word. Now, angles that are coterminal have the following property. To get them, we take our angle theta and add or subtract a multiple of 2 pi to theta to get an angle that's coterminal. So theta plus 2 pi is a coterminal angle, and it would look something like this. Now, 2 pi is a full rotation. 4 pi would be 2 times 2 pi, or 2 full rotations from past theta. Negative 2 pi would be 1 rotation backwards, and that would look something like this. This would be theta minus 2 pi. However, in each case, we have angles that are coterminal. So all of these are going to have the same sine values because they have the same, they share the same terminal side, and therefore they share the same point, which we've labeled x and y. So what we can now say is that sine of theta is simply going to equal sine of theta plus 2 pi for any angle that I plug in. Now, of course, I could add 2 pi, like I did in this equation. I could have also added 4 pi, 6 pi, 8 pi, 10 pi, and so on. Any even number as an even multiple of pi, and I would have gotten the same sine value. However, the key is that I get the smallest p. The smallest value will be the period of f. So 2 pi is the smallest such number, so the period is 2 pi. Now, you might say, well, couldn't I go smaller? What about negative 2 pi? Well, that's a negative number. That's certainly smaller than 2 pi. However, the requirement is also that p is positive. So the smallest number that's positive is 2 pi, and so therefore the period of the sine function is 2 pi. Likewise, the period of the cosine function is also 2 pi, because cosine of theta is equal to cosine of. So in summary, we have that cosine of theta plus 2 pi is equal to cosine of theta. And we also have that sine of 2 theta plus pi. Sine of theta. I misspoke there. I meant to say sine of theta plus 2 pi is sine of theta. Now, certainly, tangent of theta plus 2 pi will equal tangent of theta. So once again, 2 pi is a candidate for the period of the tangent function. However, it's going to turn out that 2 pi is not the smallest number that works. And here's the picture we're going to draw for tangent. Once again, we have our unit circle. And I'll sketch an angle theta in quadrant 1. So I have coordinates of this point I'm going to call P, has coordinates x and y. And we know that tangent of theta, by definition, is y over x. And we're going to use that to show that another angle will have the same value, y over x. Now, if I were to do one additional full rotation, I would end up right where I began, with the same terminal side, and that's described by the equation right here. However, this is not the period. There's a smaller number that works. So instead of a full rotation, what we're going to do is we're going to add a half rotation. So it'll look something like this. We have our angle theta, but now we're going to add a half rotation and end up down here in the opposite quadrant. So the terminal side now of this angle, which is theta plus just pi, a half rotation, will be in the opposite quadrant. I'm going to call it Q. However, the important thing about this angle and this point Q is that both the x-coordinate and the y-coordinates are opposite of each other. So we have the opposite of x and the opposite of y because they're in completely opposite directions. These two arrows, if you will, are pointing in opposite directions. So the coordinates that we're going to end up at are opposite for both x and for y. So we can say here that tangent of this new angle, theta plus pi, will be the ratio of these coordinates right here. So the ratio would be negative y over negative x. Now, clearly, we have that when we're dividing negative numbers, that negative divides out, so we're left with simply y over x. A negative divided by negative is simply positive, and we get y over x. However, we can see, of course, that y over x has already been determined is a value for tangent of theta. So, tangent of theta plus pi is equal to tangent of theta for every single angle. So, clearly, we have that P, our period, is just pi itself, because pi is smaller and the smallest number that works for the tangent function. So therefore, 2 pi is not the period. However, for cosine and sine, 2 pi is the period, but for tangent, the period is just pi. So, in summary, the periods for cosine and sine are both 2 pi, one full rotation, but the period for tangent is just pi, which corresponds to a half rotation.